Hey everyone, thanks for joining again and welcome to our new webinar on internet traffic in ForeFlight. Internet traffic is a feature that we released just last week in our May release. And this is a feature that allows you to view both airborne and ground traffic all over the world, live traffic, anytime you're connected to the internet on the ground. So rather than only being able to view traffic when you're connected to an ADS-B receiver, you can now use it when you're at home on Wi-Fi, at an FBO, or even just on a cellular network. This will allow you to gauge some of the activity around airports, see what's going on, what runways are in use, how aircraft are getting around weather, or if you just want to, lounge on your couch and see what's going on overhead, then this is a really great way to get some of that infotainment, as we call it. So our presenters in today's webinar will be Alex Smythers with ForeFlight. He's a private pilot and he's one of the product managers at ForeFlight. He was the one who kind of shepherded this feature across the finish line, and so he's very familiar with it, and he's going to be the one who presents most of the information about the feature in ForeFlight itself. We also have Julius Ramos. He is with FlightAware. He's an aviation sales executive in data integrations, and he is going to talk after Alex about how FlightAware gathers all of this traffic data from many different sources, such as ADS-B, MLAT, lots of different sources that they're using, and how they process that data and then send it to ForeFlight. So it's a very complex back-end process that they're doing to gather all this traffic data and forward it to us. But once it's in ForeFlight, it just comes across very smoothly. And so that's thanks to the great integration that we've set up with the FlightAware traffic feed. Our agenda for this webinar is going to start out with an overview of internet traffic, in case you haven't watched any of our videos from the last release or read any of the release materials and you're not sure how to use it. This will allow you to understand how to enable and when you can use the internet traffic layer, and specifically when the traffic layer rather will be showing you internet traffic versus ADS-B traffic. That's a very important distinction. It'll also talk about how traffic looks and how it behaves, which is also different from how ADS-B traffic generally works. So it's important to be aware that there are some differences there. After that, Alex will go over some of the potential uses of internet traffic. And following that, Julius will take over and talk about how FlightAware collects and processes that traffic, like I mentioned. And then at the very end of the webinar, we will have live Q&A. But before we begin, I definitely want to mention that you should be submitting questions throughout the entire webinar. Don't wait until the very end, because then we probably won't be able to get to your question. But if you think of a question during the webinar, you can just expand that questions panel on the right side of the GoToWebinar interface by tapping that little question mark button, and then you can type in your question and submit them, and our staff will respond to you. We'll respond to as many as we can during the presentation, and then some of the more interesting questions that we feel allow us to share something that maybe wasn't part of the main webinar, those will be answered during the live Q&A at the end. If you're having any audio problems, we recommend audio or video problems. We recommend joining from a computer, not a mobile device. So if you're watching this on your iPad or your iPhone and you suddenly lose audio or you can't see anything, try going and getting on a computer and watching it in a browser if you have one available. This session is being recorded and it will be accessible afterwards at foreflight.com/onfrequency. So with that, I'll hand it over to Alex.
All righty. Hey everyone, good afternoon if you're in the United States. I'm Alex Smythers and I am a product manager supporting ForeFlight's internet traffic feature. We've been working behind the scenes on this feature for many months now, and we think you're going to love it. There's some interesting new use cases and a lot more work to come, and we're here to share what we've got today. First, we'll talk about activating the internet traffic feature. I want to go ahead and make the note that you need to have the latest version of ForeFlight Mobile downloaded from the App Store. That's version 12.4. You can go to More and About in ForeFlight Mobile to see what version you've got at the top there. If you don't have 12.4, go over to the App Center and download the new version. So the internet traffic layer is a map layer. So many of you are probably accustomed to using the traffic layer that would show up in the layer selector here from using an ADS-B receiver or maybe even a flight simulator. So now you'll see when you are connected to the internet, again, that can be a Wi-Fi connection or a cellular connection. We'll get into some details there in just a minute. And you're on the ground, you'll see that traffic layer available in the layer selector menu all the time. So previously, like I said, it was only available and it would just pop up and become automatically activated when you connected to a compatible device. That'll still happen. You'll still automatically activate traffic when you connect to an ADS-B device, but now you have the option to go ahead and activate it when you're on the ground and you'll see internet traffic. Before we get into some of the details and what it's used for, I'm going to go ahead and make the point that this layer is not for collision avoidance. So again, a lot of you are probably accustomed to using the traffic layer for situational awareness in flight and for knowing what's going on around you in flight. And this layer is not necessarily for that. There is some delay in the amount of time that it takes to get you this data from the receivers that FlightAware has got all around the world, processed and then to your iPad via ForeFlight mobile. So we don't intend this to be used for collision avoidance, like you might supplement on a VFR flight with an ADS-B receiver. You can see in the screenshot I've got here some of the differences between internet traffic and sort of device or ADS-B receiver traffic. We'll get into those in just a minute, but you'll also notice here that the same target here, it's a screenshot taken about 2 seconds apart from each other. Again, one on ADS-B and one on internet traffic, and you see that the target's about a mile behind. So, just to really highlight that delay. Some of the sort of rules for availability, again, on the ground, you can use any internet connection that includes the cellular connection. The internet traffic feature does not use a lot of data. Just from our sort of toying around with it, we've seen that it typically takes about 10 megabytes per hour. Again, it really depends on sort of how much traffic you've got loaded at any given time, because it loads traffic based on the confines of the map and your zoom level. But it really doesn't use a lot of data. Cellular is a pretty good way to go if you've got a pretty good cellular connection wherever you are. But in the air, again, we know that cellular connections are sort of hard to come by once you get above, 5,000 or 6,000 feet, depending on where you are in the world. So we will automatically disable the traffic layer unless you are connected to an ADS-B receiver, FLARM receiver, et cetera. Or if you're connected to a source of in-flight Wi-Fi, will allow you to reselect the traffic layer and show you internet traffic. Again, we don't want users to conflict the lack of traffic targets because you don't have a good internet connection with the lack of traffic targets because there are none around. So right now that is limited to GoGo and Satcom Direct device connections, but here over the next few weeks, you'll see that expanded to more in-flight Wi-Fi connection sources. One of the unique opportunities I think to use this feature is for weather diversions and for planning. Again, that's why we've made it available with in-flight Wi-Fi, because not just using it for checking out where traffic is in the area. We know that some pilots today are using the FlightAware mobile application to look ahead, especially high performance, jet aircraft. You're up in the flight levels, and you're looking ahead. You're seeing a pretty good storm system in your path, and you want to see how other traffic in the area is getting around that, or even if you're just going into a busy Class Bravo airspace, right? How are other aircraft getting in there? And again, if you've got a good Wi-Fi connection, you can pop on this map layer and sort of see what's going on. You see here, we've got an aircraft and his intended flight plan actually on the map, and we can see that he's avoiding the storm system there by deviating between the red spots. For data prioritization, again, this map layer is still shared with device traffic or ADS-B or FLARM sourced traffic, as well as flight simulator traffic. So if you do connect to an ADS-B device, a Sentry, a Stratus, et cetera, those devices will be prioritized, and you will get data from the ADS-B or FLARM device and not from internet traffic. You won't see both at any time. You'll just see them sort of in this order. Again, if you connect to a flight simulator, you'll still get traffic from those as well. And internet traffic will sort of be last. So In order to get internet traffic, you got to make sure you're not connected to those other devices, and disconnect if you want to see internet traffic. Here's just a quick video. You can see in the upper left-hand corner, we do have an internet traffic sort of status up there in the upper left-hand corner. Again, those of you who are accustomed to seeing and using ADS-B receivers will know that we'll pop up the sort of name of the ADS-B receiver up there in the upper left-hand corner. So that's just another place to give you contextual feedback about what the source of your traffic data is at any given moment. Additionally, I want to open my layer selection window. Again, I'm connected to an ADS-B receiver here. I can see the same traffic layers automatically activated. You can also see ADS-B weather sources available for selection. You see cloud tops, ADS-B, et cetera, in there. My ADS-B receiver is at home. It's not located, sort of on a pole on the side of a building like FlightAware's are. It's located near a window, so I don't get nearly as many traffic targets here on the ground as I do when I'm connected to internet traffic. Which is a really neat advantage, again, to using internet traffic at home. You can sort of play around with it and see what's going on without needing to have line of sight of the other traffic targets in the area. And again, if you're confused about what the source of the traffic data is, you're trying to figure out what you need to disconnect from in order to re-enable internet traffic, you can go to the devices tile and see what devices you're actively connected to. I've got that in my recently selected down here in the bottom right. You can go to more and select devices and see what devices you're connected to and what sources of data they're providing. So now you know how to activate the thing. Let's talk about sort of the appearance, the behavior, and what this thing is and what it means. So if you're familiar with the traffic layer of old, again, you'll notice some similarities and differences between the markers that we're generating for internet traffic and the markers that your customer is seeing from that device source traffic. One of the first ones is that with, again, an ADS-B receiver, you'll see relative altitudes. You see plus 247 there for the Southwest Airlines flight. Means that aircraft is 24,700 feet above my current position, right? And you see over there in the other screenshot, that's 26,000 feet. Sort of MSL in internet traffic. You also see a track vector pointing out from the tip of the target there, and you'll see whether or not they're climbing or descending if they're not sitting at a comfortable altitude. For both of them, you'll see cyan chevrons when they're airborne. We'll talk about ground targets in a second. You also see a call sign. If there's a call sign present, you'll just see the call sign. And if there isn't a call sign, you should see the registration. And we won't show any information for block details, of course. And for internet traffic, of course, you're not going to get some of those other things, and you'll see pressure altitude instead of the relative altitude. So pressure altitude is pretty interesting. Again, it's uncorrected pressure altitude that FlightAware receives through ADS-B transponders. So in some cases, you might notice some oddities, such as at higher elevation airports, or when the pressure's sort of out of whack, you might see that the altitude that we're reporting is actually below ground elevation in some cases. And again, that's because we're reporting uncorrected pressure altitude. We are looking at maybe some ways we can play with that and sort of report true altitude MSL, but that's not what we're getting today. So an important distinction there. Julius will pull back the curtain here in just a little bit to tell us how FlightAware captures and aggregates position data. But at a high level, we're streaming the data from FlightAware directly to ForeFlight Mobile in virtually real time. There's not a huge delay there. We'll talk about that in just a second. FlightAware positions for airborne flights come in every few seconds or so, and we've done some great work to actually predict where each traffic target is headed based on the ground speed, track, and a number of other factors. That means that we're animating traffic targets between known positions and sort of away from their last known position to produce fluid movement. As a result of that, the position marker compared to actual position of the aircraft in real space and time can be off to some degree, but we found it's very close in most situations. Some of the places where you'll notice it might be a little bit off is when you're really zoomed into the airport environment and watching aircraft taking off and landing, it might show a little bit off to one side of the runway, and that's because, again, we're animating from positions and we might not have quite gotten their base to final turn right. You'll also see that the altitude and call sign animate fluidly to remain alongside the traffic marker. Additionally, you see I've tapped this traffic marker here and opened up a popover that's got some additional information about the traffic target, and that follows the marker along fluidly as well. You will note that in climbs, descents, and turns, heading speed and altitude are only updated with every new position report. So those values may lag behind actual because we're only getting those, every 20 or 30 seconds or so. We're not sort of fluidly interpreting what the altitude or speed might be. On the position age, you will see in that popover, we've included the age of the last received position as reported in seconds ago. Here it's reported 100 seconds ago. I was following this United Airlines flight over the Atlantic Ocean. We don't get those positions very frequently, so it's a little stale there. But that in value is the difference between the current time and the time the position was received by FlightAware receivers. So you'll see that that timer resets, and it typically resets to somewhere around 10 seconds. It'll never quite go down to 0 seconds, and that's again because there's some time, usually about 10 seconds, between the time that the position was received and the time that it gets to your device. As the timer counts up, that depicted position again is being estimated and animated away from that last actual position. So we tend to receive position reports less frequently for high altitude targets, which isn't an issue. Again, those high altitude targets aren't usually making sharp turns, so you're not going to see the animation make any significant difference from where that aircraft is in real space and time. And we do get position reports a little bit more frequently for targets that are close to the ground or on the ground. When that timer does hit 120 seconds, we will discontinue displaying that position on the map. So you'll see aircraft come and go depending on that age. Again, we don't really want to be displaying aircraft that we haven't really seen or heard from in a little bit of time. So after some amount of time, I think somewhere between 60 and 90 seconds, you'll see that the animation will stop. The marker will just sort of sit there for a little bit, and eventually it'll age out again at 120 seconds. Other key parts of the popover here, you see we've got the call sign up there in the popover, just like we do on the map. We've got the altitude there, again, pressure, altitude. We've also got the distance in nautical miles from your current position. So this United Airlines flight over the Atlantic Ocean was 2,925 miles to the northeast of my position here in Central Texas. We've got the heading displayed there in degrees and the speed in knots. In many cases, we'll also have the aircraft type there. Again, this was a Boeing 787-900, so you'll see the type code there. We tend to get this data more frequently for US registered aircraft. There's some sort of lookup going on to sort of get that data based on position information. Additionally, we're looking at how we can get that information available for non-US registered aircraft. FlightAware is sending that to us in flight plan messages, which we're actively working on consuming and bringing into the app. So you should see some more aircraft type information here before too long. Again, you'll see FlightAware as the source of the position information here, and that reported by time. There we go. Trying to play my video here. So we've also got ground markers, just like you would with the ADS-B traffic layers of old. So if you zoom into an airport environment far enough, you'll start to see these tan chevrons also jump out at you. Here I'm looking at DFW. They've got ASDEX ground radar, so we get really good information about ground targets there at DFW. FlightAware's got excellent ground coverage at thousands of airports worldwide. ASDEX is only at 35 of the largest airports in the U.S., but they've got these receivers all over the place. You can go to their website and see there's 2,000 plus airports where you'll start to see these ground markers. Since we know that these guys are on the ground, we're not going to display an altitude label for them. Again, if you zoom in far enough, just like for airborne markers, you'll see the call sign or tail number. But in this case, you won't get the altitude. You can also tap on the aircraft and you'll get a pop over and it'll say SFC or surface, just to highlight that it's on the ground. And we also do very little animation for these targets because FlightAware is sending them to us every second or two. So you see them sort of jump around just like they would from an ADS-B receiver. Again, you can monitor the age of the last received position in that popover just to understand the level of confidence in the depicted position. All right, let's move on to some of the use cases. So we've already sort of covered the weather and diversion planning use case. We'll look at that again here in a second. But we also think it's useful to use this thing to look at airports you might be flying from, checking out to see what runways are in use, how you might taxi from where you are to where you need to go. You can also use this to check arrival and departure routes, as well as for checking activity along the route and at local airports, and just for plane spotting. We think folks are going to have a lot of fun with this. So back to my weather and diversion planning scenario. Let's pretend I'm an IFR pilot in central Alabama with a piston aircraft trying to see if other aircraft are making it around this storm system in my flight path. I can look in the area. I see this Beechcraft Baron at 12,000 feet there in the area. Can also use our search bar and search for November 4111 Sierra. And if I scroll down, you can see we've got this scheduled flights search option here. That's also powered by FlightAware. You tap on that thing, you'll see recent and upcoming flight plans that were filed for that aircraft. And I can tap on that, and that'll display that route, the filed route, on the map. So again, zooming back in here, we've still got the pop over there to sort of show you where this aircraft is. We can see that guy's deviating from his planned route of flight. And it's probably because he's trying to get around the red and pink there of that storm system. So I can use this tool to sort of keep track of what other guys are doing in the area. And if I'm trying to take off from Birmingham, I might be able to sort out whether or not I might be able to go flying before the storm hits by flying around to the north. Again, if I'm a high performance pilot, maybe cruising up at 35,000 feet, I can also, pull this thing up and look to see what's going on many hundreds of miles before I even get there, just to help with figuring out if I need to go around above or otherwise plan to get around the storm system. Again, there's some interesting use cases here for figuring out how I'm going to taxi between runways or what runways in use. So here you can see I'm sitting at Houston Hobby. And let's say I might be trying to plan a trip starting from Atlantic Aviation. I'm following this, November 907 Foxtrot Juliet is actually a CRJ that's taxiing from the terminal area. It's a pretty slow day at Atlantic. There's not much going on. But, I can see that this guy's coming from the same general direction. I can see he's taxiing down Charlie for runway 31 left. So again, if I'm taxiing from Atlantic, I might expect maybe to taxi from, Yankee Kilo or maybe Charlie, and then just Charlie all the way down to 31 left. If I'm a Performance Plus subscriber, I've also got access to digital ATIS at an airport like Houston Hobby. So I can actually tap on Houston Hobby and go over to Weather and D-ATIS and see that runways 31 left and 31 right are in use. So it's a pretty cool way just to sort of know what's going on at the airport. One of the more exciting use cases is just for viewing activity at the local airport or along your planned route. I actually just read an AOPA article last week about an airport diner in Fort Pierce, Florida that had great reviews. Hopefully they're open given the global pandemic right now. But if I wanted to check that out, I might first look at local traffic and see how busy it is, right? I live here in Central Texas, and Fredericksburg, Gillespie County Airport here, is a popular place to go get pancakes in the morning. And I might use this tool just to sort of see, what's going on. Are there a bunch of people flying in? Am I going to get a seat at that diner? Right, and just sort of look to see what's going on. And again, once I land, how am I going to taxi there, right? So I know that diner's located down there at the Jet Center. So I probably don't want to come in and land at runway 10 left if I can help it, because it's going to be a long way to taxi to that restaurant. So there's some of the potential uses. I'm going to hand it over to Julius, and he's going to tell us all about how FlightAware receives and processes this data and gets it to us. Julius?
Thanks, Alex. All these features look really incredible, and it's been really cool to see this feature come to life over the past couple of months in the back end. A little bit about myself. I've been with FlightAware for 8 months now, with a background spanning 12 years in business aviation. I work on the data integrations team, as Sam had mentioned, providing flight tracking data through APIs to a variety of verticals in the aeronautical space. We at FlightAware are extremely excited to be participating in this webinar. And the purpose of this section is to give you much more insight into the data that is powering the internet traffic feature that Alex just discussed. As a trusted source of flight tracking data across the aviation industry, we felt it would be helpful for you guys to understand the data that is powering this new feature, which we will give you much more context with what you're viewing. So as far as the agenda over the next 5 minutes, I want to break it down into 3 sections. First off, about FlightAware. Many people still view us as a free flight tracking app, but don't realize how much we've evolved. Secondly, I want to talk about our data sources and coverage. So where do we gather our data from? And then lastly, talk about data processing. So this is what differentiates FlightAware to help deliver that single source of truth when it comes to aircraft positions. So while I've only been with FlightAware for a couple of months, FlightAware has indeed been around for 15 years. When I first joined FlightAware, I initially thought of it, like many of you, a free flight tracking app, and I had no idea how much went into flight tracking. In fact, you'll be surprised to know that about 75% of FlightAware's team are technical engineers. So let's just say that they're way smarter than me. While you digest some of these numbers on the screen, I'd like to give you an overview of who we are today. So FlightAware is the leader in providing real-time insights to the aviation industry. We collect, we interpret, and we distribute all of this data, predicted real-time and historical flight information. The end goal being to enhance the performance and accuracy of systems. So as you can see here on the slide, we are using machine learning technology to power the ETAs for half the US airlines, since our ETAs are more accurate than legacy methods. Our services benefit anyone touching aviation, so everyone from the biggest manufacturers through owners and operators to service providers such as ForeFlight and its pilot customer base, down to the individual traveler. So said another way, FlightAware is central to aviation. We are the trusted hub of accurate and actionable aviation data, and we're honored that ForeFlight has chosen FlightAware's data to help power this new feature. So in the next section, I want to talk more about our data sources. So although FlightAware receives data from about 60 different sources, the backbone of our data really comes from our proprietary terrestrial ADS-B network of over 27,000 ground stations now. The receivers you see here are about the size of a cell phone, and with a provided antenna can receive signals up to 300 miles line of sight. So in areas that we are looking to boost coverage, we provide these flight feeders free of charge to the host and ship them from our ADS-B lab right here from our Houston headquarters. And for aviation enthusiasts that want to build their own ground station, they can do so using our Raspberry Pi, or using a Raspberry Pi rather, which can be bought on Amazon for about $80. Because some of the audience here may be operating on 978 megahertz frequencies, I do want to note that we do have ADS-B 978 UAT coverage in the US. This coverage is limited, however, since these signals can only be read by flight feeder 978 specific models, or by PyWare users that install and set up their device to receive and decode these signals. And for those of you that are interested in hosting a flight feeder, please do go to our website, FlightAware.com, and go to the ADS-B section to apply. So next, I'm going to go through the next few slides rather quickly, but you'll be able to visually see the amount of growth and coverage we have with these ground stations. So here on the next slide, this chart needs to be updated, but you can see just how extensive the growth is of our ADS-B network over the past 5 years. It's a pretty incredible growth there. And here you can see that we have ample coverage across the globe in places that have internet connectivity. The yellow dots are our flight feeders that we distribute, whereas the white dots represent PyAware receivers. So here you can see a one-week heat map of flight activity in which we received ADS-B data. So pretty cool to see visually. You'll note that we have sufficient ADS-B coverage in the areas most of you fly. Although a large part of the audience will be using the internet traffic feature to view what is happening over terrestrial areas, I do want to point out that white flight tracks over the oceans. So these are estimated positions. We do receive transoceanic position reports about every 30 minutes of actual positions. And we're then able to estimate positions using this data in conjunction with the waypoints in the flight plan. So now let's drill down further and look at our coverage at an airport level. So for surface movement at airports, we do receive about 1 position per second from our ADS-B receivers. And you can see that we now receive data at over 3,000 airports worldwide. So here is a map of Heathrow's airport. Our ADSB team works with airports to place multiple ADSB receivers so that we can see into all the little nooks and crannies of the airport, such as gates, cargo loading areas, maintenance areas. So this is a one-week heat map, again, of London Heathrow. In the next slide, we'll show you an example of Teterboro. Much of the audience here today will be happy to see that we have service movement data flowing into your internet traffic feature at many of the GA airports that you fly into, which should provide very useful for you guys. So some of you might be wondering how we position data for aircraft that are not ADSB equipped. We are able to take mode-S transponder signals and use multilateration to determine latitude and longitude. So even though multilateration can be accomplished with 3 receivers, FlightAware actually uses 4 receivers or more for improved accuracy and reliability. So how does this work? When a particular aircraft is being received from 4 or more receivers, the server requests sufficient mode-S data from the receiver, and then we sync the time and multilaterate the position of the aircraft. So lastly, I want to explain what sets Flight apart from other data providers. So that would be Hyperfeed. On the back end, we have a processing engine called Hyperfeed, and it's processing about 20,000 aircraft positions per second. So without getting too deep into the weeds with how it works, because it is pretty extensive, our machine learning and rules-based engine rates each aircraft position from our various sources on a scale from 1 to 100, and then synthesizes that data to deliver what we consider the single source of truth. The derived aircraft position is then delivered to ForeFlight in near real time. So in conclusion, to sum this all up, a lot of technical work is happening on the back end to deliver ForeFlight all this data that you now have in the palm of your hands with the internet traffic feature. So that being said, I hope you view flight tracking a little more differently now, that you know what happens behind the scenes, and I'll turn it back to Alex.
Great, thanks, Julius. I think we have got some plenty of time here for Q&A at the end, but here's some resources for you guys. You can learn more by going to foreflight.com/traffic. Sam actually put together a great video highlighting some of the great features of this first version of internet traffic that you can access there. And there's a blog post that's linked there as well. You can watch more feature tutorials here at foreflight.com/videos and register for more webinars and watch past ones at foreflight.com/onfrequency. And if you have any questions following the Q&A in this webinar today, you can contact our awesome pilot support team at team@foreflight.com. So I think I'll turn it back over to Sam and we will get into the Q&A portion of this.
Awesome, thanks Alex. And thanks Julius for that great presentation. We got a lot of really great questions about this, so we'll move through a couple dozen of them because we do still have a good deal of time left in our allocated slot. So first up, if I have an internet connection through data on my phone and the phone is linked to ForeFlight on my iPad, can I get the flight data? So basically, they're asking if you have a Wi-Fi hotspot through your phone, can ForeFlight use that to display internet traffic? And Alex, do you want to answer that one?
Sure, yeah. So if you're connected to your phone as a Wi-Fi hotspot today, that'll be no different than any other source of internet connectivity when you're on the ground. So you'll be able to see internet traffic just fine in that way. But if you are using your phone as a Wi-Fi hotspot and you're flying, you will not be able to use internet traffic via those means today. Again, we can see that and know that that's a source of cellular connectivity, and don't want to mislead you if you don't see internet traffic data coming into the iPad. So you will not be able to see internet traffic in flight via a hotspot.
Right. Next one. Why don't we get aircraft type in the internet traffic on ForeFlight? We get that in FlightAware.
Yeah, also a good question. So today we receive a couple of different sources of data from FlightAware, and some of that information is available on their website as well. You can see their API documentation. And right now, we're mostly consuming airborne position, near surface position, and ground position data. So we've got some aircraft type information available in that data, but that's largely limited to aircraft that have an IN registration that are registered in the United States. So we did just learn that there's some additional aircraft type information that comes from filed flight plans, and we're just now looking at consuming that data and associating it with the position data that we're streaming to you guys today. So here, probably over the next few weeks or months, you'll see some additional aircraft type information pop into that popover for non-US registered aircraft.
All right, next up, I have a PioWare ADS-B receiver. Can I connect ForeFlight to it to get real-time traffic that my receiver is picking up? So basically, they're wondering if they can use their PioWare ADS-B receiver as if it were a Sentry or a Stratus or something.
Yeah, that's a really good question. Julius, I'm not sure if you have any input here, but off the bat, I don't think we have any direct integration with PioWare receivers today, so you wouldn't be able to hook that up over Bluetooth or Wi-Fi like you could a Stratus or a Sentry.
And that's correct. And thank you for hosting the PioWare receiver. We are taking that data and that's being fused into our hyperfeed processing engine and then being sent to ForeFlight.
All right, next up, will it alert you if you are close to traffic? So this question, I assume, is specifically about internet traffic, since ADS-B traffic, when you're connected to ADS-B traffic, ForeFlight will alert you for nearby traffic. But does that work with internet traffic, Alex?
Yeah, good question. So just like Sam was saying, when you're connected to an ADS-B receiver, FLARM receiver, ForeFlight Mobile is looking at, again, your sort of relative position, based on altitude and your lat long. And if you get too close, it'll display a little red pop-up, and it'll actually give you an oral warning that sort of says traffic 12 o'clock, 1 mile, etc. You will not get that for internet traffic, and there's some other things to dive into there as well. For instance, you're not going to see internet traffic in synthetic vision. So there's some things we've done there to sort of limit where internet traffic shows up, again, just because we don't want folks using that as a means of collision avoidance, since there is some delay inherently built into that process.
Next up, for low-level helicopter operations with good cellular connection, will we be able to see internet traffic in flight? Alex, do you want to briefly speak about when they may or may not see internet traffic during the flight and what our recommendation is concerning that?
Sure, yeah. So right now, ForeFlight Mobile is detecting that you're in flight if you're roughly 250 feet above ground level and have a forward ground speed of about 40 knots. So depending on what phase of flight you're in that helicopter, how fast you're moving, how low to the ground you are, you might be able to get internet traffic for a brief period of time. But again, if you exceed that sort of height or ground speed, it will be automatically disabled. So again, we don't recommend using that unless you do have a solid Wi-Fi based internet connection in flight.
Yeah, we definitely recommend getting a dedicated ADS-B receiver of some kind, like a Sentry, if you're going to be using it during the flight.
Absolutely.
Does internet traffic only display ADS-B out equipped air traffic? And Julius, do you think you could answer this one concerning what different types of traffic FlightAware ingests?
Sure. So when it comes to ADS-B out traffic, we're getting it from all ADS-B equipped aircraft. And then we have Mode S, of course, which we can multilaterate.
Yeah, so just to expand on that, Julius was talking about MLAT a little bit earlier. So non-ADS-B out-equipped aircraft will show up in internet traffic if a Mode S equipped aircraft that is squawking is within sort of line of sight of 4 FlightAware receivers. So you will see some non-ADS-B equipped aircraft sometimes, but it is going to be mostly ADS-B data.
All right, next up, just to confirm, this will not work in flight mode if you don't have onboard Wi-Fi. And the answer to that is yes. This, as we've been mentioning, and there were a number of other questions related to this. Some people were asking, oh, well, can I trick ForeFlight into thinking I have onboard Wi-Fi if I, make my iPhone a Wi-Fi hotspot? And the answer is no. ForeFlight can recognize onboard Wi-Fi, and so if you're actually connected to a GoGo or Satcom Direct network, then you will be able to enable internet traffic. But if you're not connected to one of those specific networks, whether you've got a cellular connection or you're using a Wi-Fi hotspot, then as Alex pointed out, ForeFlight will recognize based on your GPS position and altitude and speed that it needs to disable internet traffic, and that's what it'll do. So there isn't really any good way to trick ForeFlight into thinking that you're connected to one of those networks. Next one is, I fly mostly VFR with ADS-B out. FlightAware shows my flights sometimes and not others. I use flight following and some of those flights show up and some don't. What's going on with that? Alex, or I don't know if Julius could also offer some insight into this problem, but whoever wants to go first with that.
Yeah, I can take that preliminarily. It probably has a lot to do with where you're flying. Again, FlightAware's got excellent ground-based coverage in the United States and Europe and many other places, but for ADS-B out to work, just like if you're using an ADS-B receiver in the air, you've got to be pretty close or within line of sight of that receiver, which means that the range is sort of limited when you're really close to the ground. So it's possible maybe if you're flying up really high, you might see yourself pop up either in internet traffic or in FlightAware, but maybe you're not showing up when you're close to the ground, and that could be a reason for that. I'm not sure, Julius,
And
if you have
also,
anything to add there.
yes, I do want to add that another reason could be that we need to make sure that their transponder is correctly emitting their N registered number.
Awesome. All right, moving on. I've got ADS-B with a Garmin GTX 345R and a Flightstream 510 via Bluetooth and a Stratus via Wi-Fi. So this person is really decked out as far as ForeFlight is concerned, and a cellular connection sitting on the ground. What is the traffic source being shown in ForeFlight? Alex, do you want to cover what traffic source would be shown in that situation, assuming that they are connected to all of those devices?
Yeah, that's a really good question. So we've got some support articles about connecting to multiple ADS-B devices at once. So that would be the GTX and the Stratus. So those would definitely be prioritized over internet traffic. You're not going to see internet traffic if you're connected to either one or both of those devices. But then when we are seeing that multiple ADS-B devices are connected, they're going to sort of battle it out. And I'm actually not entirely sure which one's going to win, but you should be able to determine that by looking at the sort of status that you'll have in the upper left-hand corner of the Maps tab. Again, you might have remembered seeing earlier that I had internet traffic in white, and then when I was connected to my Garmin GDL39 portable, it switches over to connects. So you would be able to see up there whether or not the Stratus one or connects to the Garmin device one, and you could see, again, all the devices you're connected to on the devices tile.
All right, next question. Are there any weak spots with the ADS-B receiver coverage? Will it pick up all traffic? Julius, do you want to comment on that?
Yes, so I just want to emphasize that FlightAware does have the largest ADS-B coverage in the world. However, we do have some terrestrial gaps out there. I encourage everyone to go to the ADS-B section of FlightAware's website, and you can click on data coverage so that if you do see an area that does require more ADS-B coverage, then we'd love for you to host that ADS-B receiver.
Next up, we've seen a couple comments from people saying that when they're looking at internet traffic in ForeFlight, they don't see any of the details for internet traffic. They're only seeing the blue arrows. Alex, do you want to comment on why they might not be seeing some details?
Sure, yeah, absolutely. And another resource here, if you go to the ForeFlight blog, we've got some additional details posted there about the internet traffic feature that we didn't cover in the webinar here today. But we've done, a lot of sort of research to see, how best we can set up this feature to declutter the map, right, to allow you to continue to seeing important things like radar and different weather conditions and things on the map. As well as placing these internet traffic markers sort of all around the place without, cluttering the map. So if you're zoomed out too far, you're not going to see any details other than just that cyan chevron. Additionally, it's worth noting that we're doing some intelligent filtering based on, again, the map position and your zoom levels. So we're not streaming in traffic data from all around the world to your iPad if you're not looking all around the world, right? If you're zoomed into Texas, we're not going to show you what's going on in Maine. And similarly, if you're zoomed out really far, we're going to show you high altitude targets and not low altitude targets. And as you zoom in, you'll start to pick up more and more traffic at lower and lower altitudes. So worth piggybacking on that here briefly. But yeah, if you zoom in far enough, you should start to see altitude and call sign. Again, if you're looking at a blocked aircraft, the FAA's got a system of allowing aircraft owners and operators to block their call sign and registration from view in apps like FlightAware and ForeFlight. So if you're looking at one of those blocked tails, you're not going to see that call sign or tail number, but zoom in far enough, you should see that altitude.
All right, next up. I don't understand how internet traffic reports pressure altitude, considering that aircraft with ADS-B out are transmitting GPS altitude. Alex, would you be able to answer that one?
Yeah, so I've had some communication with some of the folks at FlightAware, and they've assured me that what we're getting is the uncorrected pressure altitude from the ADS-B transponder. So again, we're not going to see exactly where that aircraft is in space and time based on GPS altitude or true altitude.
Will we be able to search for a specific tail number? Now, that's the answer to that is kind of interesting. So Alex, do you want to elaborate on that?
Yeah, good question. You might have even seen that in one of my videos here when I was using the FlightAware scheduled flights or filed flights search. You might have seen there's a little section in there for traffic targets. So again, go back through this a little bit later on when it's posted on the website. When I search for November 4111 Sierra, you'll see that pops up. You'll see the little cyan chevron in the search feature. So today, that is limited to aircraft that are being displayed on the map. So I was just briefly mentioning again that not all aircraft, even if we are receiving ADS-B position data from FlightAware for an aircraft, we're not always going to display it on the map. It really depends on where you're looking and how far out or in you're zoomed on the map. So as long as you can generally see the aircraft target on the map, you don't necessarily need to be able to zoom. You don't need to be zoomed in far enough to see the registration or call sign, but as long as that target is on the map, you can use the search feature, search for the call sign, and it'll open up the popover and show you where it is. And just another point there, we are working on expanding that search functionality here over the next few weeks and months. So hopefully we'll be able to expand that functionality further.
Right, so next up, the aero and traffic layer is not included in the basic plan, correct? So the internet traffic layer is available for all ForeFlight subscription plans. The only time it would not be available is if you're on the 30-day free trial. If you just downloaded ForeFlight from the App Store and you get that 30-day free trial, then the layer is not available. But everyone else on any paid subscription plan who is using the most recent version of ForeFlight will be able to access the internet traffic layer. Now, the aeronautical map layer is a different, and that's a slightly older feature that we introduced a number of years ago. That is available on our Basic Plus, Pro Plus, and Performance Plus plans, which are all of our currently offered plans. However, if you are on the older $75 per year basic plan, which we don't offer anymore for people to buy new, then that plan does not include the aeronautical layer. So key point is that any of those plans that are followed by the word plus, all of those have the aeronautical map layer on them, but all plans, even not the plus plans, do have the internet traffic layer.
And again, just make sure you're on version 12.4 since we just released this thing last week.
Yeah, that's a really important thing since we do not alert within ForeFlight when a new update comes out. And so you might think you're on the most recent version, but if you haven't updated it in a couple of months, then you aren't. So you can go to more about within ForeFlight, just tap the more button and then tap the about tab kind of towards the bottom of the list. And if you look at the top of the screen, once you're in the about view, it'll show you what the version number is of the ForeFlight that you have. And if it's not at least 12.4 or 12.4.1 or something, then that means you need to update in order to see this feature. Next up, does traffic show on a geo-referenced approach plate or just on the map? So traffic does only show on the map. Now, if you have a geo-referenced approach plate and you overlay it on the map, then I believe that traffic will appear on top of that approach plate. But if you're viewing one of those plates within the plates view, then traffic will not show up there. Even though your own ship will show up in the plates view, if that plate is geo-referenced, other traffic will not appear there. Next question, now that there is more traffic displayed, especially near airports, it can be hard to pull up the airport information pop-up by clicking the airport symbol on the map. Oftentimes, my clicks near the airport symbol go to a traffic target. Is there a way to avoid this problem without having to zoom in super close to the airport?
Yeah, so I can take that one. Right now, I think the best option is to zoom in super close to the airport, or maybe to deactivate the traffic layer entirely, which again, you can do from the layer selector window. We have received some feedback here, and it is something we're looking at changing here in the near future.
All right, if our aircraft tail has been blocked, what data is presented on other cockpits about our aircraft? And Julius, do you want to answer that one? Or
I
Alex?
could take this one. For blocked aircraft that have been registered with FAA or on other blocked lists, we're still sending this data over to ForeFlight for the internet traffic layer. However, all the idents will be replaced as blocked.
So we don't even get the transponder ID in that case. We'll just get sort of the raw position information and the altitude, and that's virtually it.
Right, so if you ever see a traffic target that is only showing an altitude and it's not showing a tail number or anything, then that means that it's been blocked. Is internet traffic available in ForeFlight Canada? Yes, so two things here. First of all, if when you say ForeFlight Canada, you're referring to a specific subscription plan. Yes, it still is. If you have the Canada region or the Europe region, like I said, internet traffic is available in all ForeFlight subscription plans, no matter what level or what region you have. And the other aspect is internet traffic is global. And so if you are in Canada, then you will be able to see traffic depending on, as Julius pointed out, the amount of traffic you see is probably going to depend on how many of those PioWare receivers and different sorts of ADS-B receivers are available in that region. But you will be able to see traffic in Canada.
Yep. We do have ADS-B coverage in, I think, over 200 countries now.
Yeah, so it is really a global capability. What about UAT 978 aircraft? Is FlightAware collecting that traffic?
And yes, we do have limited coverage. As mentioned earlier in the presentation, we do have our flight feeders and PioWares. As long as they're configured to receive and decode those signals, then we will broadcast that and send that over to ForeFlight.
And just to piggyback on that, the larger audience here who might be less familiar with the ADS-B bands, the 978 or UAT band is pretty much isolated to the United States, and that was a frequency that was implemented to provide congestion relief on 1090. So in the US anyway, airline traffic is largely on 1090 and GA traffic is largely on 978. So that's where we're pointing out that there may be some gaps in the 978 coverage here in the United States, but from what I've seen and all the poking around I've done, that's pretty good.
Next one, I use Sentry Mini with my iPad, and I'm asking how my current traffic appearance will change if I start using this new delayed internet traffic feature. So Alex, can you comment on how the appearance of traffic is the same between both of those, but how they could perhaps notice a difference?
Yeah, so we still definitely encourage you to use the Sentry Mini when you're flying around. That'll be your best source of sort of local traffic information. And just like we pointed out earlier, there's some differences you'll see. Number one, again, you'll see the status information in the upper left-hand corner to know what device you're sort of sourcing your traffic information from. But then even when you're looking at the map, you're going to see relative altitude as opposed to pressure altitude. You're going to see the track vector when you zoomed in far enough, and you're not going to see smooth animation necessarily on the traffic data that's coming from the Sentry. So there's a couple of contextual ways to determine that on the map.
All right. Would you please repeat how you pulled up and show a particular flight's flight plan?
Yeah, very good question. So if you are in ForeFlight Mobile, you'll of course see the search bar up there in the upper right-hand corner. So you can use that search bar to search for a particular call sign, and it'll accept both ICAO and IATA call signs, right? WN and SWA for Southwest, respectively. And the again, the call sign, the ICAO or IATA call sign, or the tail number. If you don't have a call sign, you search for that in the search bar. You scroll down, I don't know, a couple of lines there, and you'll see a scheduled flights section that's got that call sign or tail number with it. So you tap on that, and with that, you'll see if there are any, right, the recent and upcoming filed flight plans for that aircraft or call sign. You tap on that, and that'll display the route on the map.
All right, next up, what is digital ATIS and where do we get that data? So Alex, I think you had mentioned digital ATIS during your presentation, but I'll go ahead and start just by saying digital ATIS is something that is available with ForeFlight performance plans, and it's something that will show you the actual ATIS at, I believe, something like 75, 76 major airports around the country. And so rather than having to tune into the radio to get your ATIS, you can actually just go to the weather tab in ForeFlight, and the most recent ATIS with the code will be right there. And Alex, can you speak at all to where we get that data, or is that a little bit outside of your wheelhouse?
I want to go out on a limb and say we're getting that from Satcom Direct today. The data link providers throughout the world all are capable of receiving that information and sending it on to aircraft that are data link capable in flight. So we're receiving that via an internet connection from them and passing it on to ForeFlight.
Right. Next up, at what minimum height would the multilaterated, I guess that's a multilateration algorithm triangulate mode S? And Julius, you can tell me if I totally butchered how I was supposed to say that.
No, you did just fine. To answer the question, in terms of multilateration, it really depends on how many receivers we have line of sight. So in populated areas that probably have a high density of receivers, I would say a couple hundred feet as far as the minimum height is concerned. And then for less populated areas, I would say a couple of thousand feet because we do require 4 of those receivers to triangulate in the data.
All right, next up, any plans to add FlightAware layer to ForeFlight Web? And we saw a couple of other questions of people saying, I'm looking at ForeFlight on my computer and I'm not seeing the internet traffic layer. So Alex, do you want to speak to that?
Yeah, so historically, I think ForeFlight's been a mobile-first company. We want to get all the latest and greatest features into the hands of our users using the EFB. But yeah, the internet traffic layer is a work in progress, should be coming to ForeFlight Web here in the near future.
Right, next up, will I see FlightAware traffic when paired with Sentry? So the answer is no, because if you're paired with Sentry, then ForeFlight can detect that you're paired with the Sentry, and it will prioritize any traffic data coming from your Sentry. And it's important to note that even if your Sentry is not transmitting any traffic data, for example, if you're inside your house and it doesn't have any towers, and maybe it doesn't even have any air-to-air transmission, so no traffic is showing, ForeFlight will still not show internet traffic as long as you are connected to that Sentry. So don't assume that ForeFlight isn't trying to pick whichever source is going to show the most traffic. Anytime you connect to a device that supports ADSB traffic, ForeFlight will always only show data from that device. And that's even if you do have a cellular connection when you are connected to that Sentry. So is there a filter to only see traffic up to a certain altitude? So if I will be flying lower than 7,000 feet, I can remove anything above 10,000. So first of all, you don't want to be using this when you're flying, and most of the time you wouldn't be able to anyway. But if this is just a matter of planning for a flight and you're on the ground and wanting to change what altitudes are shown for different traffic, we don't have a specific setting to do that. But Alex, can you briefly talk about how ForeFlight automatically filters traffic by altitude?
Absolutely, yeah. So no setting for you to be able to do that manually today. But like I said, we sort of intelligently show you traffic based on your zoom level. So if you're zoomed in particularly close, actually really close, for instance, you're focusing just on Dallas-Fort Worth, we'll actually only show you near to the ground aircraft. So that'll be 0 feet to, I think it might be 15,000 feet. So again, we're not going to show you an aircraft at 40,000 feet zoom across the map while you're zoomed in really close. But then it sort of increases from there. So zoom out a little bit further, you'll see up to maybe 10,000 feet. Zoom out a little bit further, maybe you're looking at the whole state of Texas. You'll sort of see up to 20-ish thousand feet, and then up to 39,000 feet, and 39,000 feet and above when you're zoomed out and looking at a large swath of the country. So we've got some more detail in the blog post you can find about how that works today.
All right, this one is a little bit off topic, but I think we can take a stab at it anyway. I understand ADSB out is requirement for all air traffic at this point. Is this correct? Alex, without going into too much detail, do you think you could provide just some high-level information about the ADSB out requirement?
Sure, yeah. So it really varies based on the country that the aircraft is operating in, right? So larger aircraft, especially commercial aircraft, and larger business aviation jets that are traveling internationally, they're very likely to be ADSB out equipped at this point because of the mandate in the United States. We actually just learned, I think this week, that the mandate for Europe got pushed back to December, but nonetheless, we know that operators are working on equipping their aircraft, and there's similar mandates in places like Canada. So, a lot of aircraft at this point are going to be ADSB out equipped, but there are going to be operators that don't operate in and out of busy airspace, right? Even here in the United States. If you're not operating in Class C airspace or greater, there's going to be aircraft out there, old Stearmans and things that don't have to be ADSB out equipped. So you're not ever going to see really those aircraft on FlightAware or in internet traffic, unless again we're picking up an MLAT signal from it and it is mode S equipped. But there's going to be aircraft out there that don't have to have any transponder. So it really depends on where you are, what sort of flying aircraft in your area is doing.
All right, we're going to answer just a few more here before we wrap it up. Can you talk about the new multitasking features you released? So I'm not going to talk about those in this webinar because it's about a different topic, but I will say that if you're interested in learning about those multitasking features and all of the really huge design changes and improvements that we made in this last ForeFlight release, please go to our website. You can go to foreflight.com/ let's see, 12-4. That is the release page for this, or you can go to blog.foreflight.com and you can find the blog article we wrote along with the release, which lays out all of those features, and we have a video showing you how to use multitasking on your iPad. So definitely go check those out when you have a minute. Next question, were these features designed primarily for a general aviation audience, or do you expect significant uptake by commercial or business pilots? So I'll go ahead and say that it was designed for everyone, both for a GA audience and also for business pilots, which is partly why we made that exception for in-flight Wi-Fi. If you're using GoGo or Satcom Direct, you wouldn't expect most or any GA pilots to have that kind of in-flight Wi-Fi setup. But the reason we put that exception in there is because when you're connected to one of those, it's more likely to be a more reliable in-flight Wi-Fi network. And so we trust that that is something that business pilots will be able to utilize on their own flights. Next up, are there any ADS-B receivers that work with ForeFlight that use Bluetooth instead of Wi-Fi to connect? So yes, I believe that all of Garmin's devices that ForeFlight works with connect via Bluetooth. I don't think that any of those connect with Wi-Fi. And there are a number of others that also connect via Bluetooth. If you go to foreflight.com/connect, that is our page that has information about all of the different external devices that ForeFlight works with. And many of those should specify whether you connect via Wi-Fi or Bluetooth. So if you're interested in which ones connect via which method, go to foreflight.com/connect to learn about that. All right, and last question here. Do we have this available in ForeFlight MFB, ForeFlight Military Flight Bag, which is the specialized app that we developed for military pilots? And I believe the answer is yes. Although if you have if you have the version of MFB from the GeoInt App Store, it is generally a couple of versions behind the normal version of ForeFlight. And so you can expect to see that there in the next couple of months, just as you would with any standard ForeFlight release. But yes, there, like I said, the internet traffic feature is available with all ForeFlight subscriptions, and that includes ForeFlight MFB. So with that, I think we'll go ahead and wrap it up. Thank you so much, everyone, for joining. For those of you who maybe didn't get your questions answered, please feel free to email team@foreflight.com. And if you think of any other question related to internet traffic, related to multitasking, or just related to anything else about the app, please email us and we can respond to it quickly and get everything sorted out. There will be a very short survey as soon as I close down this webinar. So if you don't mind just taking 30 seconds to fill that out, lets us know how we're doing, lets us know what you think of us, and it helps give us some ideas for what kind of webinars you want to see us do in the future. So thanks again to Alex and Julius. Thank you to everyone who attended and watched this webinar, and we'll see you on the next one.